Alright, so I am back. This is video 2, and I'm hoping you remember that we were just taking a look and we were noticing that if we played 20 times, it looks like, if we're just looking at the total and the percentage, it looks like 0, 1, and 2 seem to be winning a lot more times than 3, 4, and 5. And I shouldn't say a lot more times, but it's a significant amount. And the question is, why? So let's see. We have two dice, a yellow die and a green die, and you might not think that that matters, but here's the deal. If the yellow die came up a 1, the green die could come up a 1. Or if the yellow die was a 1, the green die could be a 2, or a 1 and a 3, or a 1 and a 4, or a 1 and a 5, or a 1 and a 6. So that's all the things that can happen if the yellow die came up 1 first. Well, what happens if the yellow die came up 2 first? Well, the same thing would happen, except the first number would be a 2, and then the second number would be 1 through 2, 3, 4, 5, or 6. And then that could happen for the number 3. All right, so if 3 came up first, then you would see it would be 3, 1, 3, 2, 3, 4. And why do I have such a hard time in doing this? I don't even know. And then 3, 6. And then if the yellow die came up 4 first, you would get this. 4, 1. Oh my goodness me. 4, 2, 4, 3, 4, 4, 4, 5, 4, 6, and then 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6. Uh-oh. 5, 6. Now you might have just noticed my last little mistake, and you might say, oh, well, Mr. Moore, does it really make a difference if you have 5, 6 or 6, 5? And I think that's a great question. Does it make a difference if you have 5, 6 or 6, 5? Think about it for a second. Pause this if you have to, but think about it before I answer. So if that was the question, does it make a difference? The answer is yes, it does, because this is one die coming up 5, 6, with the yellow coming up first, and then the green coming up 6. And this is yellow coming up green, 6, and 5 coming up green. Now let's see, if I were to subtract, I want 0, 1, and 2. So what I'm going to do is 0, 1, and 2. I'm going to color those. I'm going to color those ones. Let's see, what would be a nice color here? Orange. I think I'll do it orange. So I know that 1 minus 1, 2 minus 1, 3 minus 1, those would all be orange. 2 minus 1 is 1, 0, 1, 2. Those are all orange. Let's make sure I'm not making a mistake. 5 minus 2 is 3, good. 3 minus 1 is 2, 1, 0, 1, 2. And those are orange, all right. 4 minus 1 is 3, so that doesn't work. 4 minus 2 is 2, 1, 0, 1, 2. Now those are all orange. 5 minus 1 is 4, 5 minus 2 is 3, 5 minus 3 is 2, 1, 0, 1. And those are orange. And then that's 5, 4, 3, 2, 1, 0. So let's see, how many would be, how many do we have altogether? We have 1, 2, 3, 4, 5, 6 times 1, 2, 3, 4, 5, 6. We have 36. So out of the 36, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Out of the 36, that means 24, there's 24 ways to win if you have 0, 1, and 2. Well, let's say we're now going to take a look at if you had 3, 4, and 5. Well, if you had 3, 4, and 5, you don't have so many ways to win, do you? Look at this. You have far fewer. By the way, this is the NCTM question, so I do want to thank the people, the lovely people over at NCTM for providing such wonderful, wonderful questions. So 3, 4, 5, 3, 4, 5, And I hope they don't mind me giving out the answers online, because that's the... So look at this. You are twice as likely to win any particular round as you are if you have 0, 1, and 2 over 3, 4, and 5. So the probability that you're going to win a round is going to be equal to 24 out of 36, which is 0.667. And the probability that these guys are going to win any round would be 12 out of 36, which is 0.333. Which means this would be about a 67% chance of winning. And this one only has a 33% chance of winning. So it's no surprise that when we take a look at our data, oh, look at this. How many times did they win? 13 out of 7, 65 to 35. That was very coincidental, and I obviously have no control over it. It happened again. Now it's 70-30, very close. 50-50, I mean, it can happen. 65-35, these are all really, really close. 60-40, 70-30, 60-40 again, 75-25, 65-35. You can see how close these actually are to the theoretical. So once again, this is theoretical. This is what should happen, and this is empirical. This is what does actually happen when we run our trials. And the nice thing is, if you wanted, you could use this and extend it on and on and on really, really far. In any event, I hope you learned something. I hope, if nothing else, you learned how to use some formulas. Formulas start with equals. Here are a couple of little formulas we did. And that you understand how using a mathematical model can help understand why something works or how something works, and how theoretical probability and really gives us an idea as to what's happening. The law of large numbers says that if we did this for many, like hundreds of trials, it would come out very, very close to these numbers, 67% and 33%. And like I said, just doing 20 values gives us a fairly close, on many of these occasions, very, very close to what we actually thought it should be. All right, and that's it. Take care.